Okay, so last time what we did was we started probability. Okay, so so here is the definition. Remember now with probability, we're assuming all outcomes are equally likely. Now, does that have to be the case in real life? I want to say no, but for this class, that's what we're going to be assuming. Then, for any event, E, remember, an event is a sub-collection of outcomes. The sample space, remember, is the collection of all outcomes. Now, the event, E, the probability of it, which is denoted by this, remember, it's equal to the number of outcomes corresponding to event E divided by the total number of equally likely outcomes. In other words, since E is a collection of outcomes, it's the number of outcomes in E, right, when E is viewed as a collection, divided by how many outcomes there are in the sample space. So it's the number of outcomes in E divided by the total number of outcomes in the sample space. We also saw last time that if E is any event, right, this E bar here is just the complement of E. Basically, it's everything in the sample space, all the outcomes that are not in E. E bar also happens when E does not happen. If E does not happen, then one of the other outcomes in the sample space that's not in E occurred. Hence, it's an E bar, and so E bar occurred. E bar is actually called the complement of E. And now, why do we care about this? Well, this equation is very useful. We went through it last time. What's nice about it is if you know one of these values, P of E, or P of the complement, the probability of E, or the probability of the complement of E, if you know one of them, you can easily get the other from this equation. And that's always really good. It makes it a little bit easier. Sometimes one of these may be easy to calculate as opposed to the other one. Okay, so that's good. Now today, what we're going to see is this notion of odds. Essentially, the odds for an event or against an event, as we'll see, it's really just another way of expressing how likely an event is to occur. How likely the event is to occur or not occur. It's related to probability. It's not quite the same thing, though, as you'll see. I mean, the odds, we hear about that in society, in the world around us. For instance, what are the odds of winning the lottery? What are the odds if you're at a casino, let's say, and you're playing a card game, you might wonder, or one of those, I think they call it slot machines, what are the odds of winning? What are the odds of getting the jackpot? That kind of thing. So it is related to probability. It's not quite the same thing, though, as we will see. First, let's define what are the odds in favor of an event. Well, remember, for an event, we use a capital letter like E. The odds in favor of or for an event, it's the number of ways the event can occur to the number of ways the event E cannot occur. Notice it's a ratio. It's not like probability, which is a fraction. It's a ratio. That's what the colon here is telling us. So basically, it's the number of outcomes in E to the number of outcomes not in E. It's another way of saying it. You can, however, calculate it using probability. Namely, we have this definition. The odds for an event E is the probability of E divided by the probability of not E, meaning the probability of an outcome that's not in E occurring. Excuse me, the probability of E not occurring, that's better. In other words, it's the probability of E divided by the probability of the complement of E. Okay, that's what the bar here is supposed to indicate. What's nice is from this equation, we can get the probability of that E bar pretty easily. Namely, we have this. The probability of E divided by 1 minus the probability of E. So this is really good. So basically, we can calculate it easily if we know the probability of E, of event E. Okay, so let's do an example. So I was going to do an example, but there's something I must say first. Actually, a few things. When we talk about the odds, again, we write it as a ratio, not as a fraction. Probability is written as a fraction. We write it as a ratio like this. And in words, we're going to use the word 2 with it when describing odds. Like 1 to 5, or that's what's over here, 1 to 5, or 5 to 6, something like that. This won't come up too much in this class, but with probability, though, we like to use the word in. 1 in 5, or 1 to 5 would be odds, whereas with probability, it would be 1 in 5. You know, it's just terminology that people like to use. So we had, okay, so before we had the odds in favor of an event, we have the odds now against an event. Let me just quickly fix this. It went off the slide a little bit. Easy to fix. There we go. The odds against an event, that's just the number of ways the event cannot occur to the number of ways the event can occur. Again, that's just what it is by definition. The number of ways that E cannot occur to the number of ways that E can occur. It's actually, well, I'll get to this shortly. Actually, I was going to say it later, but I'll say it now. It's actually the odds in favor of an event E, but you invert it or flip it. And again, it's written as a ratio. And just like with odds in favor of, the odds against an event, you can calculate it using probability. It's just the probability of not E occurring divided by the probability of E occurring, of event E occurring. Or again, the probability of the complement divided by the probability of the event E occurring. And just like before, the probability of the complement is 1 minus the probability of E, of event E occurring. And again, it's just the odds in favor of flipped, turned upside down, so to say. And it's always good with odds to write it as a ratio. I know here it looks like you want to write it, you can write it as a fraction. You're really supposed to write it as a ratio. Okay. So here's our first example now. Let's find the odds for rolling a die and getting a 3. Now, it's a standard 6-sided die. We have seen the sample space before. It's the outcomes 1, 2, 3, 4, 5, 6. Right? You know, those are the numbers you can get rolling a 6-sided die. So our event E here would be 3, rolling a 3. So of course here, the E only has one outcome in it, right? The number of ways E can occur, that is the number of outcomes in E, is just 1. Now, how many ways can E not occur? Well, that's 5, right? Because there are 5 outcomes not in E. In other words, the complement of E is this, the other outcomes besides rolling a 3. So in this case, the odds in favor of E, the event E, which is rolling the die and getting a 3, are 1 to 5. 1, 2, 5. So we just use the definition directly. We could also use probability because the probability of E occurring is 1 out of 6, right? As we have seen before. And that is, so then the odds in favor of E would be 1 over 6 divided by 1 minus 1 over 6. Here, I'm using 1 minus the probability of event E. I could have just divided by the probability of the complement of E, because we know what that is. This is equal to 1 over 6 divided by 5 over 6. And by basic algebra, we get 1 over 5, and so we write it as a ratio, 1 to 5. I shouldn't say basic algebra. This is true based on the first slide I showed you in this chapter. Basically, if you have a fraction over a fraction and the top and bottom fraction have the same denominators, those denominators cancel. And that's essentially what's happening here. Notice also the odds in favor of rolling the die and getting a 3. It's not the same as the probability. Right? The probability of event E is 1 over 6. The odds in favor of E are 1 to 5. So they're not quite the same thing.